This is CPM Precalculus, Chapter 1, number 138. A right triangle has legs of length 4 and 7. So we know we have a right triangle, and the legs are length 4 and 7. So we have a right triangle. The legs are basically all the sides, the two sides other than the hypotenuse. So this is the hypotenuse, it's the longest side, and it's also across from the right angle. So the legs are going to be this side and this side. Well, 4 is smaller than 7, so I'm going to say this is 4 and this is 7. Okay. Find the measure of the angle opposite the shorter side. So here's the shorter side, here is 4. The angle opposite to it is over here, right? And B is find the measure of the angle opposite the longer side. So here's the longer side, 7, and the angle opposite is up here. Okay, so when we're given a triangle, let's start off by labeling it. Okay, so if I say this is vertex X, Y, and Z, then this is going to be opposite that is little z. Opposite angle Y or vertex Y is little y, and little x is opposite angle X. Okay? So let's start and just look at part A. We're asked to find the measure of the angle opposite the shorter side. So we want to find, let's use a different color. We want to find opposite the shorter side is this angle, right? So we want to find angle Y. So what do we know about angle Y? Well, since it's a right triangle, we know we can use our trig functions, being sine, cosine, and tangent. Okay, so if we wrap the angle Y inside tangent, inside cosine, and inside sine, inside cosine, inside tangent, we're going to get ratios, right, using SOHCAHTOA. So we know sine is going to be opposite over hypotenuse. Well, opposite of y is 4, right? Hypotenuse is going to be z. We don't know z. Cosine of y is going to be adjacent over hypotenuse, CAH. So adjacent is going to be 7. And hypotenuse again is z. We don't know z. And finally, tangent of y is going to be opposite OA, so opposite over adjacent is going to be 4 over 7. Okay, since we don't know z, we could solve for z, right, using the Pythagorean theorem, and then use one of these, but we already know all of these things. We don't need to use these equations since we know 4 and 7, the sides opposite and adjacent to angle A. So, using tangent of y equals to 4 over 7, how do we find the angle measure y? Well, remember, what we can do is, if tangent is wrapping our function, we use the inverse of tangent to unwrap it. So if we take the inverse tan, right, tan to the negative 1 means the inverse tan function, and throw this as the input, then the tangent inverse and tangent cancel each other out, right? Because that's wrapping and unwrapping. But in order to do this on one side, we have to do this side to the inverse tan as well. So we're left with angle y is equal to the inverse tan of 4 over 7. Okay? So we can plug that into our calculators. Let's just see our mode to make sure we're in degrees mode. Otherwise, we're going to get an answer in radians. So if we do inverse tan of 4 over 7, we get 29.74 degrees. Okay, if I round to 2 decimal places, because this 4 is less than or equal to 4, so it keeps it the same. So that's approximately 29.74 degrees. Okay, that's degrees. If we did this in radians, let's do it also in radians. So let's put mode into radians. Let's put our calculator in radians mode. So if we did this in radians, we would get 0.5. Well, this 9 rounds the 1 up. So we would get 0.52 radians. And you just put RAD is short for radians. Okay? So the measure of the angle opposite the shorter side is either 29.74 degrees or 0.52 radians. Okay. So now let's move on to part B. So before we do that, let's write in here, we know this angle Y is 29.74 degrees or 0.52 radians. Okay, so let's move on to part B. B is asking us to find the measure of the angle opposite the longer side. So this is the longer side, right? And here is our angle. So we're looking for angle X. So what is the measure of angle X? Well, again, we look at, you can use our sine, cosine, and tangent, our trig functions. So SOHCAHTOA. So sine of angle X is equal to opposite over hypotenuse. Well, now the opposite of angle X is side X, little x, or 7. Hypotenuse is still Z, right? So cosine of angle X is adjacent. Well, adjacent to angle X is side Y, or 4 over hypotenuse Z. So it's 4 over Z. And tangent of angle X is equal to opposite over adjacent, so it's equal to 7 over 4. So just like we use tangent in the part A, we're going to use tangent in part B because cosine and sine both have the unknown Z. And we could solve for Z, but it's going to be faster if we just use tangent. Okay, so we're going to use tangent. We have tangent of angle X is equal to 7 over 4. And remember, to unwrap tangent, we have to use the inverse tan function. If we do it to one side, we have to do it to both sides, right? So this is going to cancel out. Tan and inverse tan cancel out. We're just left with what's inside the parentheses, x. So our angle x is equal to the inverse tan of 7 over 4. Okay, so let's bring out our calculator. Right now we're in radians mode. So if we do the inverse tan of 7 over 4, we get approximately 1.05 radians. If we put our mode into degrees, our calculator into degrees mode, do the same thing, we get 60.26 degrees. Okay, this 5 here rounds this 5 up 1. Okay, so now we have x equals to 60.26 degrees. All right. What a faster way to do part B, okay? We could have also just remembered that if we add up all three angles, if we add up angle X, angle X plus angle Y plus angle Z, if we add up all three angles in our triangle, we always get 180 degrees, right? If we don't know angle X yet, right, we're trying to solve for angle X. We know angle X plus angle Y we found is 29.74 degrees, and angle Z is our right angle of 90 degrees, equals to 180. So we can use this to solve for angle X2. We could combine these in the left, so 90 plus 29.74. So we have angle X plus 119.74 is equal to 180. Now we can subtract 119.74 from both sides. So 180 minus 119.74. And we get angle X is equal to 60.26 degrees as well. Okay, so we could have done it this way using our sine, cosine, tangent are trig functions. Or we could have, since we had angle y and angle z already, we could find the third angle in a triangle by using the fact that we add them all up, we get 180 degrees, and we could solve it this way. So either way, we're going to get the same answer. And this is going to end CPM Precalculus Chapter 1, number 138.